Hello everyone, this is Vishal and you are watching Replica. Today I have something really exciting to share. Unihiker board from DFRobot. Here we have a Python Unihiker board. It has two buttons, button B, button A and a home button. A C-type port for powering this board up and some pinouts header for connecting sensors and one USB for connecting peripherals. And it has 512 MB RAM and 16 GB of flash memory which amazed me because generally development board doesn't have this size of flash memory, and it would be cool to make a FPV camera for my RC car, but after researching I discovered that streaming video directly on Unihiker is not possible, which was disappointing. I also did not have a USB camera on hand, so I started thinking about other ways to play with its screen or display some photo to it. That's when I had a light bulb moment. What if I created a retro style camera using the Unihiker board? Retro and vintage products are really popular right now. You can see on Instagram trends, and I love old school, so I decided to build a retro camera using the Unihiker board. Once I finalized the idea, it was time to get to work. There are few things which we used to make the Unihiker based retro camera. Two Li-ion batteries, 3.7 volt, a 5 volt regulator, which is indeed for this project because Unihiker generally operates with 5 volt, but when you see the documentation of Unihiker, that says 3.3 volt is sufficient for operating the Unihiker, but it is not true. When I tried to operate the board at 3.3 volt, it fluctuates the display. The fluctuation of display occurs. That's why we don't try to run Unihiker from 3.3 volt. That's why I am using LM7805 voltage regulator for this project, because I use two 3.7 volt lithium ion cell for powering the board. After connecting it in series, it will make 7.4 volts, which is not good for Unihiker health. That's why we are using voltage regulator. And here we have ESP32S3 sense. It is made for portable gadgets, so it has a battery connection in it that helps it to operate the board in very low voltages like 3.8 to 4.2 voltage, as documented on ESP32S3 sense documentation page. You can check it also. Now first step, setting up ESP32S3 sense. I recommended to use official Seed Studio documentation to learn how to upload the code to the ESP32S3 sense. After successfully running the blink test, you are ready to go. Next, upload the camera web server 3.0 code. Which is the link in description. This code sets up a web server using ESP32S3 sense that allows captured images. Once uploaded, you'll get an IP address which creates a network connection using either a mobile hotspot or Wi-Fi. The ESP32S3 sense acts as a server and Unihiker is client. The ESP32S3 sense capture images and send them wirelessly to the Unihiker, and Wi-Fi router or your phone hotspot will work as network. Step 2. Programming the Unihiker. Now let's establish a wireless SSH connection using Visual Studio. Follow the official documentation for setting up a Unihiker. Once done, load the camera program. It handles displaying, saving and deleting images. If you are wondering how to review the images, don't worry, we have another code for it. This program displays images one by one on Unihiker screen, organized by time date stamp. To make this project portable. Keep the mobile hotspot on. As a device communicate via socket communication, without internet access, it will impossible to communicate and it will impossible to capture the image. Once everything set up, now I'll show you how to operate this camera, how to click images from it. This is the final product. This is the camera, you can see, and because the battery of the camera is ran out, so I am connecting it through a charger. You can connect it to a power bank, so I am connecting it. Here it is. Then press the home button. Now you have to select run programs. Then after run programs, you have to select root folder. In root folder, you have to select camera.py, or you can select whatever you name your program at root folder in VS Code. My camera program name is camera.py, so I will select camera.py. After selecting camera.py, the screen is look like this. If it is showing blank screen, don't worry, you are good to go. You have to just press the button B for clicking images. This is B button, by the way. And you have to press A for deleting all the images. I know this sounds hilarious, but it is what it is, because we have some memory problems, and for running CPU fluently, I make the code in this way. So let's took an image. See, this is me. One more. Okay, I am taking my image. This is my photo. Once more. See, now now you can see the photo. Okay, after clicking the photos, now I like to review the photos. So for reviewing, we have another program for it. So you have to just click on the home button. Okay, after clicking the home button, you will see this type of, and then you have to select the second program which you have written in the VS Code. I saved it as photo_show.py. So I select it. This is showing some random images I clicked. This is some photos which I have clicked in my past days. For more details and troubleshooting problems related to this project, you can check out my DFRobot community post, link in description. And that is it for today project. It took me 1.5 weeks to make this project. So please like, share if you found it interesting.